Good morning, students. Welcome to 12th standard physics class. Students, today's topic is on AC generator. AC generator or alternator is an energy conversion device. It converts mechanical energy used to rotate the coil or field magnet into electrical energy. Alternator produces a large scale electrical power for use in homes and industries. Working principle of AC generator. Alternators work on the principle of electromagnetic induction. The relative motion between a conductor and magnetic field change the magnetic flux linked with the conductor, which in turn induces an EMF. The magnitude of the induced EMF is given by Faraday's law. Parts of an AC generator. Alternator consists of two major parts, namely stator and rotor. As their name suggests, stator is stationary while rotor rotates inside the stator. In any standard construction of commercial alternators, the armature winding is mounted on stator and the field magnet on rotor. The construction details of stator, rotor and various other components involved in rotor contains magnetic field windings. The ends of field windings are connected to a pair of slip rings attached to a common shaft about which rotor rotates. Slip rings rotate along with rotor. To maintain connection between the DC source and field windings, two brushes are used which continuously slide over the slip rings. Next, armature windings. Armature windings is the coil wound on the slot provided in the armature core. One or more than one coil may be employed depending on the type of alternator. Two types of windings are commonly used. They are single layer winding and double layer winding. Components of AC generator: stator, rotor, alternator, brush box, slip rings are the components of AC generator. Advantages of rotating field over rotating armature in alternator. Alternators are generally high current and high voltage machines. The stationary armature rotating field construction has many advantages. First one, the current is drawn directly from fixed terminals on the stator without the use of brush contact. Next, the installation of stationary armature winding is easier. Next, the number of sliding contacts, the slip rings, is reduced. Moreover, the sliding contacts are used for low voltage DC source. Last, the armature windings can be constructed more rigidly to prevent deformation due to any mechanical stress. The next topic is single phase AC generator. In a single phase AC generator, the armature conductors are connected in series so as to form a single circuit which generates a single phase alternating EMF, and hence it is called single phase alternator. Consider a stator core consisting of two slats in which two armature conductors PQ and RS are mounted to form single turn rectangular loop PQRS. Rotor has two salient poles with field windings which can be magnetized by means of DC source. Working. The loop PQRS is stationary and is perpendicular to the plane of the paper. When field windings are excited, magnetic field is produced around it. The direction of magnetic field passing through the armature core let the field magnet be rotated in clockwise direction by the prime mover. The axis of rotation is perpendicular to the plane of the paper. Assume that the initial position of the field magnet is horizontal. At that instant, the direction of magnetic field is perpendicular to the plane of the loop PQRS. The induced EMF is 0. This is represented by origin O in the graph between induced EMF and time angle. When field magnet rotates through 90 degree, magnetic field becomes parallel to PQRS, the induced EMF across PQ and RS would become maximum. Since they are connected in series, EMF are added up and the direction to total induced EMF is given by Fleming's right hand rule. The direction of the induced EMF is at right angles to the plane of the paper. For PQ it is downwards and for RS upwards. Therefore, the current flows along PQRS. The point A in the graph represents this maximum EMF. For the rotation of 180 degree from the initial position, the field is again perpendicular to PQRS and the induced EMF becomes 0. This is represented by point B. The field magnet becomes again parallel to PQRS for 270 degree rotation of the field magnet. The induced EMF is maximum but the direction is reversed. Thus the current flows along SRQP. This is represented by point C. Then on completion of 360 degree, the induced EMF becomes 0 and is represented by the point D. From the graph, it's clear that EMF induced in PQRS is alternating in nature. This graph mentions variation of induced EMF with respect to time angle. Single phase means ஒரு கட்ட மாறுதிசை மின்னோட்ட மின்னியற்றி. Next, three phase AC generator. Three phase means triple. மூன்று கட்ட மாறுதிசை மின்னோட்ட மின்னியற்றி. Some AC generators may have more than one coil in the armature core and each coil produces an alternating EMF. In these generators, more than one EMF is produced. Thus, they are called polyphase generators. If there are two alternating EMF produced in generator, it is called two-phase generator. In some AC generators, there are three separate coils which would give three separate EMFs. Hence, they are called three-phase AC generator. In the simplified construction of three-phase AC generator, the armature core has 6 slots cut on its inner rim. Each slot is 60 degree away from one another. 6 armature conductors are mounted in these slots. The conductors 1 and 4 are joined in series to form coil 1. The conductors 3 and 6 form coil 2 while the conductors 5 and 2 form coil 3. So, these coils are rectangular in shape and are 120 degree apart from one another. The initial position of the field magnet is horizontal and field direction is perpendicular to the plane of the coil. 1. As it's seen a single phase AC generator, when field magnet is rotated from that position in clockwise direction, alternating EMF epsilon 1 in coil 1 begins a cycle from origin O. The corresponding cycle for alternating EMF epsilon 2 in coil 2 starts at point A after field magnet has rotated through 120 degree. Therefore, the phase difference between epsilon 1 and epsilon 2 is 120 degree. Similarly, EMF epsilon 3 in coil 3 would begin its cycle at point B after 240 degree rotation of field magnet from initial position. Thus, this EMF produced in the three-phase AC generator have 120 degree phase difference between one another. Next topic is advantages of three-phase alternator. First one, for a given dimension of the generator, three-phase machine produces higher power output than a single-phase machine. Second one, for the same capacity, three-phase alternator is smaller in size when compared to single-phase alternator. Third one, three-phase transmission system is cheaper. A relatively thinner wire is sufficient for transmission of three-phase power. That's all for today's class, today's homework. Students, watch this video 2-3 times and read the question and answers thoroughly. After reading the question and answers, write everything in your classwork notebook and then send the script to my WhatsApp number. Thank you, students, and God bless you all.